Java Review: Methods, Classes, and Inheritance. A method is a grouping of code which performs a specific task in Java. By grouping code, we begin to see the pieces as objects, each with their own purpose that can be called to when needed, as opposed to another approach known as top-down programming, where all of the necessary code is written sequentially in the program. This style of programming is called object-oriented programming. In Praxis code, Java methods are referred to as procedures. Praxis code procedures act in a similar manner to Java methods. Procedures in Praxis code are what provide programs with reusable features. Reusability in programming is the practice of modularizing code into procedures and being able to use those procedures repeatedly. Reusability enables programmers to write less code and reuse code that they've already written. The syntax for a new procedure looks similar to how we have written Praxis code classes. There are a few types of procedures that we'll learn about that will change what is provided in the return type section of the procedure. There are two overall types of procedures. There are built-in procedures. You've used many of them with strings already, and you'll be introduced to various built-in methods throughout the course as they're needed. And there are user-defined procedures. The user writes them depending on their need and purpose, and there's two types, those that return values and those that do not return values. When a procedure does not return a value, we use void as the return type. Notice we also changed the procedure name to something appropriate for the example. So we have void, and then the procedure name is age. For procedures that have a return value, we must specify the type and use the command return. If we want a procedure to return an age, we would write the following: int, instead of void, because this returns an integer, int age, and then we have return int here inside the procedure. Parameters are not required in procedures, but do allow you to gather information from outside of them in order to be used within the procedure. Parameters are declared and initialized with data within the procedure header like below. This makes them local to the procedure and only exist within that structure. So here we have int param1, double param2. A procedure can take as many parameters or arguments as it needs, but can only return one data value. Although void procedures do not return a value, they are able to output information by printing. Notice how print statements here is used to print out three statements even though it is a void method. So void print statements will print, "Hello there, welcome to CS, I'm your teacher Anne." It is considered good practice to use procedures inside your programs to organize your code. This is a common way that code will be provided on the Praxis exam. In a class that repeatedly prints out common and known information, we can reuse procedures instead of writing new procedures each time they're needed. Instead of typing out all of the print statements multiple times, we just call a print statements method twice. So here we have class practice, void main, we have a new string student called new. If this string equals new, we want to print the statements and then print your new. If the student is not new, we want to print those same statements, but then at the end print your not new. By choosing to create procedures that include parameters, modifiability can be easily incorporated into a program. Parameters and global variables within a class can increase the versatility of a program, allowing it to work with many cases and types of input. Programs that are modifiable don't just include parameters within procedures. The programs are designed in a way that they can adjust when finding an error or needing the program to fulfill a new requirement. A program might need to be modified to perform any of the following: change functionalities, strengthen security, incorporate new platforms or protocols, and improve user experience. We've already seen a few examples of classes in Praxis code, so we'll begin to work with multiple classes. Oftentimes, in programs, multiple classes are needed to organize code into common behaviors and characteristics, similar to how we just organize procedures. All procedures exist within a class. On the Praxis exam, though, you may not always see the class header written. There may just be a procedure. A class header looks like the code below. Class field, and then we have procedures, and within those procedures we have statements. As with Java and other programming languages, many classes can exist within one program. The more you work with classes, the harder it will be to keep track of them or know what each one does and what fields and methods it has. This is where commenting becomes ever more important. Get into the habit of creating comments at the top of the class as well as embedded in the code. Oftentimes, code segments will be provided but only include a comment of what that segment is intended to do, not actual code. Let's look at an example. You are working for a university that wants you to write a program that will store information about various stakeholders, i.e. students, faculty, staff, administration, etc. How would you go about solving this? Let's start by designing some classes and outlining what we would include in the classes. So we have student, faculty, and staff. The students will have a name, ID, GPA, and a graduation year. Faculty members will have name, ID, salary, the courses they teach, and their department. Staff members will have their name, ID, salary, and role. Praxis code has the ability to allow objects to take on behaviors of other objects. This is the ultimate use of object-oriented programming. When objects share specific qualities, it is much easier to write the code once in a class, many times referred to as the parent class, and then have other classes, known as child classes, access its behaviors to use. We have a parent class called person, with some basic expected behaviors. We can create a child class of the parent class called faculty. The notation extends is used to call to the parent class from the child class in the declaration statement. So we have class child class extends parent class. So for this example, we would create the faculty class like this. Class faculty extends person. For our first attempt at implementing inheritance, let's design a simple class structure, also called a class hierarchy. So person is at the top, that's the parent class, and there's two children classes, faculty and student. Every stakeholder is a person with certain behaviors. From there, everyone will have more specific behaviors unique to each role. The idea is that every class is built off of another class. This is called an is-a relationship in inheritance. For example, a faculty member is a person. The is-a relationship is a useful way to test out whether it makes sense to have one class inherit from another. A student is a person. A faculty is a person. A philosophy class is not a person. A person is not always a student. A car is a vehicle. A motorcycle is a vehicle. A convertible is a car. An engine is not a vehicle or car or motorcycle. A pickle is a cucumber. A cucumber is not always a pickle. We can revisit our general outline and expand our hierarchy to include some basic code structures. All right, at the top is person class because all people have name and ID. And then students, more specifically, have GPAs and graduation years. Employees have salaries and departments, and those employees are either faculty, which teach courses, or staff, where they have a role. There is a difference between one class calling to another and a class inheriting from another. A restaurant program creates server objects, for example, by calling to the server class like this. Class restaurant says server Joe is a new server. End restaurant. In this example, the two classes restaurant and server do not share any properties, and server is a restaurant doesn't make sense. So we can conclude that inheritance is not needed here. This is an example of two classes having association. On the other hand, a company class can create bank account objects in the same way through associating two classes. The bank account class could be a parent class for different types of accounts that the company class could call to instead, like savings or checking. The connection between company class and the accounts will still be association, since the only thing happening there is the creation and use of the objects, not sharing of attributes. But the connection between bank account and savings and checking classes will be that of inheritance, because savings and checking is a bank account. Consider the three classes below, A, B, and test. What do you think the output will be when we run the test class? The output is class B did something. Both classes A and B have their own public procedures called do something, and both have the same parameters, in this case, none. Therefore, Praxis code will run the procedure of the subclass B. This is called overriding. Praxis code will first look inside the class of the object calling the procedure to see if a matching procedure with the correct parameters exists there. If not, it will look to the superclass to find the procedure. By simply changing the do something procedure in the B class to accept a parameter and keeping all of the rest of the code the same, Praxis code will instead run the procedure from class A. Let's see that in action on the next slide. By adding that parameter string x, Praxis code will now look to the superclass for a method to run that has no parameters, and it will find the method do something in class A. It will print class A did something. Overloading is similar, but differs in that it is when two procedures with different parameters in the same name exist within the same class. For example, the code below has two procedures called void display, but they each have a different number or type of parameter. If two procedures in one class are exactly the same, a compiler error will occur as with the case below. Void display int A, void display int B. In both overloading and overriding, the program knows which procedure to use based on the arguments passed or which class is called. The following are acceptable formats for overloading: a different number of parameters, like in the previous example, different order of parameters, so here we have two procedures and one has a car then an int, the other has int then car, that's okay. Or you could have different types of parameters. Two procedures called display, one takes a car, one takes an int. Encapsulation is when a class is wrapped up into a black box. When all of its inner workings are hidden from other classes, it is said to be encapsulated. Data in the class can then only be accessed by public procedures. This can be done by making all instance variables and global variables private, and then creating public methods to access and get the values for the variables. Encapsulated classes have procedures that do nothing but allow other classes to read and write their global variables. Advantages of encapsulation. Data hiding. Users have no idea about the inner implementation of the class or how the class stores values. Increased flexibility. You can determine which variables of the class are read-only or write-only depending on the requirement. Reusability. Classes can be easily changed and reused because all information is encapsulated in one place. And testing code is easy. Your standard classes, such as the string and math classes, are encapsulated. You will never need to see inside them or know how their code is implemented in order to use them.